Very often students ask me, Miro, from where I supposed to start solving the problem? You're supposed to always look at the component which has two pieces of information. So if you are going to look at resistor R1, we have just one piece of the information, right? R3 has one piece of information, but R2 has two pieces. We have resistance and we have current. So if I have resistance and current, I can find voltage across that resistor. So I can say that V2 is equal I2 times R2, where I2 is equal 3 milliamps times R2, which is equal 20 kiloohms. This is equal 60 volts. So we found V2. Also, please notice that these two resistors, I mean R2 and R3, are in parallel. So in parallel circuit, the voltage across each component is the same. That's why I can write that V2 is equal to V3. This is equal 60 volt. So if I have voltage across resistor R3, I can find the current which goes through resistor R3. So I3 is equal V3 over R3. V3 is equal 60 volts over R3, which is equal 15 kiloohms. This is equal 4 milliamps. Okay, so we found I3. Because we have current which goes through resistor R2 and resistance, and I have current which goes through resistor R3 and resistance, I can find the powers. So I can say that P2 is equal I2 raised to the second power times R2. I2 is equal 3 milliamps. We have to raise this to the second power times R2, which is equal 20 kiloohms. So P2 is equal 180 milliwatts. Okay, so this is power at resistor 2. Again, we can look for power at resistor 3. So I have I3 raised to the second power times resistor R3. This is equal, I3 we found is 4 milliamps raised to the second power times resistor R3, 15 kiloohms. This is equal to 40 milliwatts. Okay, so we found power P2 and power P3. We have two currents, I2 and we found I3. If you are going to add them up, you are going to find the current which goes through the resistor R1. Please notice that current which goes through this resistor is going to also be equal to I total, because I total goes directly into this resistor. So I can say that I total is equal I1, and this is nothing else, just the sum of the currents I2 plus I3, where I2 is given 3 milliamps plus I3 4 milliamps. This is equal 7 milliamps. Okay, so we found I total and I1. So if you want to find V1 you can find from Ohm's law. This is I1 times R1, where I1 is equal 7 milliamps times R1, 5 kiloohms. So V1 is equal 35 volts. If I have current and resistance, I can also find the power. So P1 is equal I1 squared times resistor R1. So this is 7 milliamps raised to the second power times R1, 5 kilohms. This is equal 245 milliwatts. Okay, so this is power at resistor R1. Okay, so we found P1. And if it comes to V3, we also found V3, so I can cross this out. We found also V1, I can cross this out. So next, we can find voltage source. Okay, how I can find the voltage source? Voltage source is equal to the sum of voltages V1 plus voltage V2 or voltage V3 or voltage V23. Please notice that voltage V2 is equal to V3, or we can call this also V23. This is KVL. This voltage, right? I mean voltage drop across resistor R1 plus the voltage drop across these two resistors. As I said before, the voltage across these two resistors is the same, will give me voltage source. So this is equal V1 35 volts plus V2 60 volts. This is equal 95 volts. This is my voltage source. Next, I can find total power. P total is equal I total times voltage source. I total is equal 7 milliamps times voltage source 95 volts. This is equal 665 milliwatts. Okay? If you want to verify your answer, you're supposed to add all powers together. So P total is equal P1 plus P2 plus P3. So if P total equals P1 is 245 milliwatts plus P2, which is equal 180 milliwatts, plus P3, which is equal 240 milliwatts. Everything together is equal 665 milliwatts. Please notice that the answer for P total, right, which we got before was 665 milliwatts, and we got the same answer, right, from addition of all powers together. So it means that our calculations are correct, and we can say that the problem is solved.